Hello everybody, my name is Jake Adams and I'm a sophomore at Sammy State University, engineering tech major. As you can see here, I'm at the Huntsville Municipal Airport here in Huntsville, Texas, and today in this video I'll be demonstrating how the law of science can be used in everyday life. Alright, if you look over here, we have the orange and white tower. That's what we call an IFR tower. It glows green and white during night so that way pilots can tell the difference between the airport lights and the city lights. Helps them find their way here. What I'll be doing today, demonstrating the law of sines, is I'll be getting a distance from here to the very top of the tower. That will give us a hypotenuse for our measurements. Alright, that gives us a measurement of 10 degrees and 92 yards for our hypotenuse. Alright, now we're going to get the remaining side that we need to use the law of sines. Alright, that gives us 16 yards. Let's go figure this out.
Alright, buddy, I've written down all of our known and unknown variables for our measurements. Alright, I've written down side C equals 92 yards, which was from where I was standing to the top of the tower. That's how far it was. I've also written down side A of 16 yards, which is from where I was standing at the base of the tower to the very top. And I also have angle A, which is 10 degrees, is from where I was standing on the ramp to the top of the tower. All right, I've also written down the law of sines, which states side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. It's a bit of a tongue twister, so just bear with me for a little bit. All right, whenever we're solving for an unknown angle with the law of sines, it's going to look a little bit like this. And remember, whenever you're doing calculations in the law of sines, always make sure your calculator is in degree mode. You can always check it by hitting the mode button. It'll be about two selections down, will be rating in degrees. Always make sure it's in degrees. All right, since we're trying to find angle C, I'm going to use side A over sine of angle A to help me find it. All right, and this is what it's going to look like. Sine C equals side of C times sine of A over side A. All right, and that when written out, it's going to look a bit something like this. Sine C equals 92 sine 10 degrees over A, which is 16. All right, when we put that into our calculators, we come out with sine C equals 0.998. All right, whenever we get here, we have to use the inverse of sine to find what 0.998 is. All right, and whenever you put in the inverse of sine, hit second and then sine again. That'll be the inverse of sine. And that will come out to C equals sine inverse 0.998. All right, and that itself will come out to C equals 86.38. And there is our angle for C. So I'll write that over here, 86.38. All right, make sure you got it. I'm about to erase it. All right, now that we have side A and angle A and side C and angle C, now we can find the remaining angle, which is obviously 180 minus 10 minus 86.38, which comes out to, let me write that down. B equals 180 minus 10 minus 86.38. All right, and that leaves us with 83.62, I believe. Yes. All right, and bam, now we have all the angles that we need. 93.6. All right, and when we're finding B, we have to convert it so it will look a little bit something like this. A sine of B over sine of A. Sine of A. All right. And we write it all out, it will look a little bit something like sine of A 3.62 over sine of 10. All right. Then we put that into our calculators, and that comes out to B equals 91.61. All right. 91.61. All right, now we have every variable that we could find. We have every angle, we have every side, and that's how you use the law of sines. And again, my name is Jake Adams, student at Sam Houston State University, engineering technology major, signing off.